Hello friends. Here's a question that seems simple but gets to the heart of how computers work. Why do computers only use zeros and ones? The answer comes down to physics. Every circuit inside a processor is a tiny switch, and a switch has exactly two states, on and off. On maps to 1 and off maps to 0. That is it. Engineers found it far more reliable to build hardware that only needs to tell apart two states rather than 10. So binary is not an arbitrary choice. It is the most natural language for electronic hardware. Everything your computer does, every calculation, every image, every video, is built on top of this simple idea. In this video, we are going to take that idea and learn exactly how to read a binary number and convert it to decimal. Alright, before we convert anything, we need to understand place values. You already use place values every day with decimal numbers. The ones place, the tens place, the hundreds place. Binary works exactly the same way, except instead of powers of 10, we use powers of 2. Starting from the rightmost bit, position 0. The place values go 1, 2, 4, 8, 16, and keep doubling as you move left. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, and 2 to the 4 is 16. The key habit to build right now is always reading binary from right to left when you assign place values. The rightmost digit gets the smallest power. Once these values feel familiar, the conversion method practically builds itself. Now let me show you the method. The rule for converting any binary number to decimal has exactly 2 steps. Step 1. Multiply each binary digit by its place value. Step 2. Add all those results together. That is the entire algorithm. If a bit is 1, its place value gets counted. If a bit is 0, it contributes nothing to the sum. 0 times anything is 0. So those positions simply drop out. This means you only need to add up the place values where you see a 1. The table on screen shows this layout clearly. Binary digit, place value, and result for each position. Read the digits right to left, assign the powers of 2 we just covered, multiply, then sum. A clean, repeatable process, every time. Next, we will walk through a real binary number from start to finish. Here's the interesting part. Let's convert 1101 in binary to decimal right now. We have 4 bits, so we assign place values right to left. Position 0 gets 1, position 1 gets 2, position 2 gets 4, position 3 gets 8. Now we multiply each bit by its place value. The leftmost bit is 1 times 8, that gives us 8. Next bit is 1 times 4, that gives us 4. Next is 0 times 2, and here's where zeros shine, because that term is simply 0 and drops out entirely. The rightmost bit is 1 times 1, giving us 1. Now we sum everything. 8 plus 4 plus 0 plus 1 equals 13. So 1101 in binary is exactly 13 in decimal. Notice how only the positions with a 1 actually shaped the answer. The 0 bit was invisible. Alright, let's bring it all together. The powers of 2 method comes down to 3 repeatable steps. First, read the binary number from right to left and assign each bit its power of 2, starting at 2 to the 0. Second, multiply each bit by its place value. Third, sum the results. And remember, any 0 bit contributes nothing, so you can simply skip those positions. That is the complete method, and it works for a binary number of any length. One habit that will make you faster: memorize the powers of 2 up to at least 16. 1, 2, 4, 8, 16. Before our next video, try converting 1010 in binary to decimal on your own using these exact steps. Work through it step by step. The answer will confirm the method works. Thanks for watching Webronaq. See you in the next one.